We've been discussing rates of reactions, where molecules will react if they collide with the right energy, the right orientation, the right speed. So what if we wanted to make these reactions faster? Well, if you can improve upon any of those things, then you're going to make the chemical reaction faster. So I love this infographic. This infographic is from compoundchem.com. I obviously did not make it. You can see the information at the bottom. But I wanted to focus on each little part of this infographic and talk about how that helps make reactions happen faster. So first off, let's zoom in on collision theory. Collision theory is based upon the idea that the correct orientation is what's going to allow a reaction to proceed. Where you can see here, if you've got them coming in at the wrong orientation, you're not going to have a reaction proceed because they needed to line up with one red and one green and one red and one green. And when that happens, you produce little pairs that have one red and one green. And so if they come in at the wrong orientation, they're not going to react. And so collision theory would include the idea that if you can control how molecules interact, you're going to speed up the rate of reaction. And that's pretty important. There's many facets of chemistry that are all about lining up different molecules or even proteins or antibodies in the correct orientation. That way you can increase the speed or the rate at which these molecules interact. The next one we can talk about is you increase the rate of the concentration. Because if you increase the concentration, they're going to find each other more frequently in solution, and therefore that rate of reaction is going to increase. Because if you decrease the concentration, then they may not find each other. And so it's all about increasing the frequency of those collisions. The next idea is that you can increase the temperature of a reaction. By increasing your temperature, you're increasing their velocity, the average mean square speed of each of the different molecules. And so because of that, they're going to collide more often and they're going to collide with more energy and the energy needed to react. And so by simply increasing the temperature, you're going to increase how often they collide and the energy at which they have when they do collide, both really making it so the reactions proceed more frequently. The next one I'd like to talk about is increasing the surface area. So if molecules only react on the surface, so say you have a salt that's in a cube and it needs to react as sodium ions and chlorine ions, keeping it in a cube means you're only going to have those molecules on the surface that are reacting. Whereas if you dissolve it in something, allow it to break apart, now you have a lot larger surface area, and so the different molecules can move around and react. And so the idea is if you increase the surface area, you're going to increase the number of successful collisions. The next one is increased pressure. This is similar to the idea above it of increasing the concentration. As you increase the pressure, you're forcing them to come in a lot closer proximity to each other, therefore increasing the rate at which these particles collide. So you increase the pressure, you're going to increase the rate of a reaction. Last but not least, you can use a catalyst. Now, what is a catalyst? A catalyst is something that you add into a reaction that is not used up. And what it does is it lowers the activation energy of that compound. So remember we talked about before about how there's like this hill that you must roll the ball up and it must get over the hill. And then once it does, it's got enough energy to form the products. It's the same way, except for basically a catalyst is a bulldozer, and that bulldozer comes over and just takes away the top of the hill. So now your hill is a lot smaller. I know when I played soccer, hill repeats were the worst. And if you could have bulldozed the top of that hill, my energy level would have been a lot happier. And so that's all a catalyst is with a catalyst, you're lowering the energy barrier. Without a catalyst, that energy barrier remains the same. And so the idea is you're basically making it easier to create products by lowering the energy needed for a reaction to occur. And that is the last and final thing that we want to discuss for how you might speed up a reaction and make reactions happen faster.